Behind me is a giant mural made out of 5 sheets of plywood that depicts the geometry of the circle that's drawn in base 12. So it's a base 12 geometric pattern is drawn on our Cartesian plane where the length of 1 is divided into 12ths instead of tenths. So I go over all this in my book called Understanding Base 12 Math, How to Draw the Perfect Circle Using Dalzell Geometry, available through Amazon. And this diagram gives us access to the base 12 version of pi, which is different than what we are familiar with in base 10. There's a number that is the result of the equation that's built into this geometry because we're literally dividing the diameter of each of these circles into its circumference. And we're doing so in such a way that there's a little gap between all of these black circles. So those black circles represent the solid line of the diameter. And then when we divide it up and disperse it around the circumference, we do so in such a way that there's a little space between them all. It's an equal space, so all those points are equidistant from their neighbors and also equidistant from the center. So this is a geometric pattern that isn't accessible in base 10 because the structure of the base 10 Cartesian plane doesn't give us the same lattice points, the points where the horizontal and vertical lines are crossing. There's points that are accessible in base 12 that aren't in base 10, and it's those base 12 defined points that enable us to draw this diagram perfectly on the base 12 Cartesian plane, or the Dalzell Cartesian plane. So this is Dalzell Math. DalzellMath.com is my website. You can go there to find more information about base 12, that it is a completely legitimate form of math. And what I'm doing now is just explain to everybody how to grow the circle once we've established the geometry of the first ring, the geometric structure of this ring here. You can see there's a complete ring of circles, and I've gone over the second, third. We're just working on the fourth ring of the diagram now, where we can draw lines that are paralleling the degree line. So going through and just generating all the points on each consecutive ring as we progress from ring to ring. The ultimate or finished version of the diagram for 360 degrees requires 30 rings. You see here in this diagram, this mural only has 15. So it's a very large diagram. And then once we get to the completed version of the diagram for 360, we realize we can just keep going and literally plot millions and billions and trillions and gazillions of points on the circumference of the circle, all perfectly positioned, everything symmetrical and balanced.